All right, so this is 10.4 notes. We were talking about inscribed angles and polygons, and inscribed in the circle chapter means inside. So we have inscribed angles and intercepted arcs. Those go with each other. So an inscribed angle is an angle with a vertex on the edge of a circle with sides that are chords. All right, so here we have this angle, angle ABC is an inscribed angle. You can see here's the vertex. There's the vertex, and we have a chord and a chord. So that is an inscribed angle. So it's an angle that starts on the edge and goes out. So this is the angle right here. Then we have the intercepted arc. And the intercepted arc is the arc created by an inscribed angle. And it's formed between the two chords. All right, so here, the arc that we are talking about, this is that arc. So it's the arc that's in between where those two chords intersect the circle. So this is the intercepted arc AC. And that's created by the angle ABC. So those are the two pieces that we're going to work with. So there is something about the measure of an inscribed angle, and then there's a theorem that goes with it. So the measure of an inscribed angles theorem is that, make sure that's in frame, the measure of an inscribed angle is half the measure of the intercepted arc. So what do I mean by that? So the measure of the inscribed angle is half the intercepted arc. Well, here, this is my inscribed angle, and this is my intercepted arc. Well, say if that was x degrees, the actual angle is created by, it would be measured from the central angle. So that's actually 2x degrees. So whatever this angle is here, this would be twice as much. So here I can say the measure of angle ADB is 1/2 of the arc. Sorry about that, very loud. So that the measure is 1/2 the arc, or I could write it as the arc is 2 times the measure of the angle. So it just depends on how you look at that. Then we have the inscribed angles of a circle theorem. So that is if two inscribed angles, remember those are the angles on the edges. So if two inscribed angles of a circle create the same arc, or rather the same intercepted arc specifically, then the two inscribed angles are congruent. So you can kind of see it as almost like it's being projected on. So here I have angle D. It's projecting out and it's creating this intersected arc. But this angle is also projecting out and creating that same arc. So because they're both creating arc AB, those angles have to be congruent. So in this case, the measure of angle ADB is going to be equal, or rather, take out the measure. So angle ADB is going to be congruent to angle ACB. So we'll do a couple practices with that. So I want to find the missing piece. So it's either going to be the inscribed angle or the intercepted arc. So here I have the intercepted arc, so I want the inscribed angle. So the inscribed angle is half of the intercepted arc. So in this case, it's going to be 45 degrees. Here I have the inscribed angle and I want the intercepted arc. So hold on, here is, so HGF is going to be 45 degrees. Here, VT is going to be 38 times 2, so that's going to be 76. And here I want to know what ZW would be and what is ZXW. So ZXW, this angle right here, is creating this arc as well as this. So because both of these angles are creating that arc, they're actually equal. So the measure of angle ZXW is going to be 72. And then that arc is going to be twice as much of both of those, so 144. So that's how we're going to use inscribed angles and the intercepted arcs. And then in part 2, we're going to talk about polygons in circles. So now you can watch that video.